हमारे लेटेस्ट अपडेट्स पाने के लिए चैनल को सब्सक्राइब करें और बेल आइकन को दबाना बिल्कुल ना भूलें ताकि हमारे सभी नोटिफिकेशंस आपको सबसे पहले मिलें। Digimentor Education is India's best platform to prepare for GATE, NTA, UGC, NET and PGT Computer Science। ज्यादा जानकारी के लिए हमारी वेबसाइट www.digimentor.com पर विजिट करें।
Hello everyone. In this video, let us try to understand how can you combine cells so that you can minimize a Boolean expression using K-maps. So as I told you, in the K-maps, we use the gray code, and with the help of these gray codes, you can combine two adjacent cells so that one of the variables can be minimized. Okay, so let me first show you with the help of example, then you will be able to understand. So here you can see this is representing a 4 variable K-map. So in a 4 variable K-map, any two adjacent cells, even if you take row wise or even if you take column wise, any two adjacent cells, they are having a change of only 1 bit, correct? So if they are having a change of only 1 bit, that means you can combine these cells so that you can minimize one variable. Okay, so you can make cells of size 2, you can make cells of size 4, you can make cells of size 8 and so on. I mean, the cells you are going to make will be in the powers of 2. Okay, let me explain with the help of examples, then you will understand. I'll come back to this diagram later on and then again I'll tell you कि हम कैसे कर सकते हैं, how can we do it. So look at this example here. Look at this example. We have the following expression. This is representing a Boolean expression and this expression is representing A complement B complement C plus A complement BC. ठीक है, क्या रिप्रेजेंट कर रहा है? A complement B complement C plus A complement BC. Now in this expression, if you follow the rules of Boolean algebra, then you can take A complement and C as common, and then inside we are going to have B complement plus B. That means only one variable is changed. This is the combination, and the result will be A complement C. And the same one here can also be represented by this K-map. So this K-map, this location is representing your A complement, B complement C, and this location is representing A complement B, C. And these are two adjacent cells, they are having only 1 bit of change, therefore I can combine them and I can remove the variable which is changing. So here you can see this 0 is changing to 1. So because 0 is changing to 1, so I can remove this variable here and I can write this 0 and this 1. This 0 is representing A complement and this one is representing C. Therefore, the solution is A complement C. Now in the second case, we have the following expression. This is your Boolean expression. So in this Boolean expression, the variable A is changing. So I can represent this by this cell. So this cell here, this cell is representing your A complement BC, and this cell here, it is representing your ABC. So from the rules of Boolean algebra, you can take A complement as you can take BC as common. If you take BC as common, then inside you will get A complement plus A. So because you will get A complement plus A, that is why I can remove the variable A complement plus A. You can clearly see here A is changing its value. The value of A is changing from 0 to 1, so I can remove this variable. Here you can see, here we have BC and BC are having the same values. उनकी value जो है वो constant है, वो same है. Even if we have these two cells which are on two different ends, अगर इन सभी cells के बीच में you have change of only one variable, if you have change of only one variable, then you can combine these cells. जैसे ये जो cell है, this cell is representing the value A, B complement, C complement, and this cell is representing the value A, B, C complementation. So mathematically, I can take A, C complement as common. So here you can clearly see A is not changing its value. The value of A is same in both the cells, as well as the value of C is also same. C is having 0, C is having 0. Only B is changing its value. So because B is changing its value, so I can remove the variable B and I can get A, C complement. So यहाँ से you can get A and you can get C complement. The solution will be AC complement. Okay, I'll take a lot of examples. Initially, I have to explain you how to do it. But when you will do it in the practice, it will hardly take you 5 seconds to solve the problem. तो बहुत easily आप solve कर पाएंगे. First, I'm trying to explain what the concept is, what is the reason behind we are going to combine the cells, and then when we will solve the problem, you will see how easy it is to solve the problems using the help of K-map. Now here, this is a 4 variable K-map, and the expression that we have is A complement B complement C complement D, and this is A B complement C complement D. So this is representing A complement B complement C complement D. This is representing A B complement C complement D. So that means in these two cells only one variable is changing. Which variable is changing? Only this variable A is changing its value. The variable A is changing the value from 0 to 1, and all the other variables are having exactly the same value. So I can just write all the other variables here. So after writing all the other variables here, removing A, I will get B complement C complement D. So this is our solution here. तो ये आपका solution होगा. Okay. Now look at this one. Now this K map is representing 3 minterms. यहाँ पर 3 minterms है आपके पास. The first minterm is A complement B complement C. The second minterm is A complement B C complement, and the third minterm is A B C. Represent them with the help of a K map. So in this K map, we are having a 3 variable K map. So in the 3 variable K map, you are going to have total of 8 cells. Out of these 8 cells, 3 cells are having a value 1, other cells are having a value 0. So these 3 cells which are representing a value 1, they are representing minterms. ये minterms को represent कर रहे हैं. And these cells which are having a value 0, they are representing the max terms. वो max term को represent कर रहे हैं. So what I can simply do is, I can take a combination here which is BC. I can take a combination here which is, so in this combination, BC is same, only A is changing the value. And in this combination, A complement is same, only B is changing its value. So simply I can do, from this combination I can say it is A complement is same as well as C is same, and from this combination I can say it is BC is same, therefore the solution will be A complement C plus BC. तो जो solution होगा वो आपका A complement C plus BC होगा. You can also do the same with the help of Boolean expression. आप इसको Boolean expression से भी कर सकते हैं. Okay, so I think here you can see we have 4 variables. आपके पास 4 variables है यहाँ पर. We have the variables which is A complement B complement C. We have A complement BC. We have ABC, and we have A B C complement. So I am representing all of these variables here. Now there's something very interesting. Okay, so here this subset is possible. You can say this subcube is possible. We will not call it as a rectangle, we will call it as a subcube. Right? Why I'm calling it as a subcube? Because these are coming in the powers of 2. For example, 2 raised to power 0. So cell can be of having only one. मतलब जो आपका subcube है, that can be of having only one element, right? So here you can see each of these cell is representing a subcube. So that is 2 raised to power 0. A subcube of size 1. We can have subcube of size 2. 2 raised to power 1. So here you can see this is representing a subcube of size 2. This is representing a subcube of size 2. This is representing a subcube of size 2. We can also have subcube of size 2 raised to power 2. That means 4 cells. We cannot combine 3 cells in a K map. We can combine 4 cells. We can have a subcube of size 2 raised to power 3. That is 8 cells. We can have a subcube of size 2 raised to power 4. That is 16 cells. So basically, whenever you are going to combine these variables, these subcubes are having a size which is in the powers of 2. The size of each of these subcube will be in the power of 2. Okay. Now in this case, if you look at it very clearly, यहाँ पर क्या हो रहा है? So both of these ones are included in this subcube, as well as both of these ones are included in this subcube, but these two ones are included in 2 different subcubes. ये जो 2 ones हैं, I mean this one and this one, they are included in 2 different subcubes. ये 2 अलग-अलग subcubes में included है. So we do not have to take it. हमें को नहीं लेना है. Why we do not have to take it? Because this is not an essential prime implicant. ये एक essential prime implicant नहीं है. Okay, so we will discuss about it. हम लोग इसके बारे में discuss करेंगे. Step by step we are going to discuss about it. Just now, just know that we have 3 terminologies. One is we have implicant. Second is your prime implicant. Correct? And the third one is your essential prime implicant. Third is essential prime implicant. तो हमारे पास 3 टर्मिनोलॉजीज हैं यहाँ पर. एक है implicant, दूसरा है prime implicant और तीसरा है essential prime implicant. Let me give you a brief idea. अभी मैं I'm not discussing in depth regarding implicant, prime implicant or essential prime implicant. We will discuss about these 3 terminologies in the next video. Right now, let me just give you a brief idea. So every subcube is an implicant. Even if we have a subcube of size 2 raised to power 0. जैसे if I just talk about this single one, this is an implicant. This single one is an implicant. This single one is an implicant. This single one is an implicant. So every subcube, right, is an implicant. Even you can see this is a subcube of size 2. It is also representing an implicant. It is a subcube of size 2. It is also representing an implicant. It is a subcube of size 2. It is also representing an implicant. Implicant means every subcube is an implicant. And the size of subcube will be 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. Any of these subcubes will be representing an implicant. Clear? Then we have prime implicant. Prime implicant means any implicant which is not completely a part of another subcube, which is not completely a part of another implicant. जैसे let me explain with the help of example. देखो, this one is representing an implicant, this one is representing an implicant, but the problem here is both of these ones are also a part of third implicant. ये जो दोनों वन है वो एक तीसरे implicant के अंदर भी आता है. Both of them are coming within this third implicant. So basically this third implicant which is not inside another implicant, then that is called as prime implicant. This is called as prime implicant. जैसे let me show you here. So this one and this one simple, these both are implicant, but this bigger subcube is a prime implicant. Now this one is an implicant, this one is an implicant, correct? But this bigger one is a prime implicant. Then you can say, sir, ये जो bigger subcube है, for this bigger subcube, some part of this subcube is coming in this implicant and some part of this bigger subcube is coming in this subcube, right? तो इसका कुछ part है जो इस वाले subcube के अंदर आता है, कुछ part है इस वाले subcube के अंदर आता है. So that means see this subcube is not entirely a part of another one. मतलब entirely का मतलब क्या है? You have a box and you are putting something inside the box, right? This something is completely inside the box. अगर ये completely इस box के अंदर है, इसका मतलब है this box is a prime implicant and this inside one is a right only implicant, correct? But if some part of this box is coming in this box, some part of this box is coming in this box, right? Then we will not call this one as a implicant. This will become a prime implicant, correct? So basically every prime implicant is also an implicant. हर एक prime implicant जो है वो एक implicant को represent करता है, okay? Then third one is essential prime implicant. तो essential prime implicant का मतलब क्या है? Is there any prime implicant which is covering a one which is not covered by anyone else? जैसे if you look at this implicant, ये जो implicant है, this implicant is a prime implicant, right? But at the same time this implicant is also essential prime. ये जो implicant है यहाँ पर, ये एक essential prime implicant भी है. Why? Because it is covering this one and this one is not covered by any other subcube. इस one को किसी भी subcube ने cover नहीं किया. And here in this subcube is also essential prime implicant because it is covering one term. ये एक ऐसी term को cover कर रहा है that is not covered by any other prime implicant. But if you look at this subcube here, this subcube, so this subcube is just an implicant, but it is not essential prime. This subcube is just a prime implicant, but it is not essential prime. ये सिर्फ एक prime implicant है, ये essential prime implicant नहीं है. It is not representing an essential prime implicant. Why it is not representing an essential prime implicant? Because it is not covering anyone that is covered by others. मतलब ये कुछ ऐसी term को cover नहीं कर रहा जिसको कोई और cover ना कर रहा हो. ये दो terms को cover कर रहा है and both of these two terms are covered by other essential prime implicants. ठीक है? So in any of your solutions, we should have all the essential prime implicants. जैसे this is representing an essential prime implicant. This is also representing an essential prime implicant. So in any of your solution, all of your essential prime implicants should come, right? But for prime implicants, we have to choose whether this prime implicant should come or should not come. So if I am giving a solution for this equation, now this one should be present in the solution. ये जो है ये किसको present कर रहा है? A complement C. And this one is also essential prime implicant. ये किसको represent कर रहा है? AB. So in any of your solution, all the essential prime implicants should be there. But for some prime implicants, we have to choose whether it should be there in the solution or it should not be there in the solution. Okay? We will discuss about it. हम इसके बारे में ज़्यादा डिटेल में discuss करेंगे. We are going to have a complete discussion about it. Even if you could not understand anything, इवन इफ यू जस्ट नो कि हमारे पास ये 3 टर्मिनोलॉजीज है एज ऑफ नाउ, दैट इज फाइन. You should only know that there exists a terminology which is implicant, there exists a terminology which is prime implicant, and there exists a terminology essential prime. अभी आपको सिर्फ ये 3 terminologies को करना है, because we are going to have a complete video, we are going to have a complete discussion on this topic. Okay, right now just understand for this K map we can get multiple solutions, but here if I say I want to have a unique or I want to have a minimized Boolean expression, so in that minimized Boolean expression all the essential prime implicants should be there, and for prime implicants we have to make a choice. ठीक है, if you solve the same expression using Boolean rules, how can you do it? From these two I can take A complement C as common, from these two I can take AB as common, and then B plus B complement is 1, C plus C complement is 1, therefore the solution is A complement C plus AB. Okay. Okay, let me take another example here. So in this example we are creating a subcube of size 4. यहाँ पर जो subcube है उसका size 4 है, and all of these 4 cells should be adjacent. ठीक है, जैसे in this case is representing an expression. ये किस expression को represent कर रहा है? This is representing a function f of ABC, and in this ABC we are having summation 4, 5, 6 and 7. It is having summation 4, 5, 6, 7, 7. That means it is having 4 min terms. Now when you are putting all these 4 min terms here, now in this case there are a lot of implicants are possible, there are a lot of essential prime. Okay, let me show you implicant क्या है यहाँ पर, essential prime implicant क्या है, how many implicants are there and how many essential prime implicants are there. First of all let us just look at what are the number of implicants. यहाँ पर कितने implicants हैं, what are the number of implicants. So this single one is an implicant, second implicant, third implicant, fourth implicant. Then we have 5 implicant, 6 implicant and 7 implicant. And then this bigger one is your 8 implicants. So in this one we have a total of 8 implicants. आपके पास यहाँ पर 8 implicants है. We have a total of 8 implicants. Clear? Then how many implicants are there which are prime implicants? यहाँ पर अगर आपके पास 8 implicants हैं तो इन 8 में से कितने prime implicants हैं? How many of them are prime implicant? Okay. So this bigger subcube here, this bigger subcube is only one prime implicant. यहाँ पर prime implicant सिर्फ एक ही है. It is only having only one prime implicant. We do not have more than one prime implicant, because even if you take this subcube, so this subcube is a part of this bigger subcube, correct? So this cannot be a prime implicant. Even if you take this subcube is also a part of this bigger subcube. So the biggest subcube that you can have, the biggest subcube that you can make, that biggest subcube is going to represent a prime implicant. Okay? And how can you make subcube? आप subcube कैसे बना सकते हैं? You can only combine those cells where there is a change of only one bit, right? So here between these two cells only one bit is changed, between these two cells only one bit is changed, between these two cells only one bit is changed. That is why I can combine this subcube of size 4. And when you look at this subcube, then what are the variables that are changing? So C is changing as well as B is also changing. So B and C both are changing. Only variable that is remaining the same is A. Therefore, because only A is remaining, so I can say that this entire K map is representing only the variable A. In the same way, if you look at this K map, now in this K map, we have all of these locations are representing a 1. ठीक है, तो अगर आप इसको थोड़ा ध्यान से देखेंगे, if you look at it very clearly, then you will find that this is representing a function f of a, b, c, d, which is equal to summation 3, 7, 15, right, and 11. ठीक है, so it is representing summation 3, 5, 3, 7, 15 and 11. Okay, now again here you can combine subcubes. So this is the biggest subcube you can have, and this biggest subcube is representing your prime implicant as well as it is also representing essential prime implicant. Now in this biggest subcube only CD is not changing, CD is remaining the same, A and B both are changing their values. Therefore if you look at the solution is CD, right? Solution जो है वो यहाँ पर होगा CD. Okay, Now look at this one here. So here three examples are there. How are the other subcubes you can make? Now in this example, you can combine these four cells. Why I can combine these four cells, sir? Why? Because here, first of all, it is having a size of 4. And if you look at these two cells, only one bit is changed. If you look at these two cells, only one bit is changed. If you look at these two cells, only one bit is changed. But if you look at these two cells, only one bit is changed. So basically, we can have a subcube of size in the powers of 2. So this is 2 raised to power 2. So the subcube of size 4. Okay. Here again, if you look at this cell and this cell, only one bit is changed. Why? Look at this cell. This cell is representing A, B, C complement, D complement. And this cell is representing A, B, C, D complement. So here you can see only C is changing, and A, B, D complement is same. So that is why I can combine this subcube and this subcube. In the same way, I can combine this subcube and this subcube. In the same way, I can combine these two subcubes and these two subcubes. So I can take a subcube of size 4. तो यहाँ पर मैं subcube जो है उसका size 4 ले सकता हूँ. I can take a subcube of size 4. Now in this subcube of size 4, what variable is not changing? You will see A is not changing. As well as you can see that D is not changing. C is changing as well as B is changing. Therefore, in your solution, you will get AD complement. The solution of this K-map is AD complement. Okay? So you can clearly see it is AD complement. And if you look at this K-map, again you will find that this subcube and this subcube, only one bit is changing. This subcube and this subcube, only one bit is changing. This subcube and this subcube, only one bit is changing. This subcube and this subcube, only one bit is changing. So I can combine all of these four corner subcubes. जितने भी आपके corner के subcube है, आप सभी को combine कर सकते हैं. And if you combine all of these four subcubes, then you will see that D is not changing here, as well as B is not changing here. That means the solution will be D complement and B complement. So we have BD complement. Okay. So this is basically B complement dot D complement. ये B complement dot D complement है. So there is some printing mistake. You can rectify the mistake. Here also it is A D complement. Here is B complement dot D complement. Okay. Now again here, but you can see we have one in this location. We have one in this location. One in this location. One in this location. One in this. One in this. And one in this. Now in this case, we cannot have a subcube of size 7. हमारे पास size 7 का subcube नहीं हो सकता. The subcubes can be of size 2. The subcubes can be of size 4. The subcube can be of size 8. We cannot have a subcube of size 7. So now what I can do here is I can make this subcube. It is of size 4. I can make this subcube. It is of size 4. I can make this subcube. It is of size 4. So basically, in every question, in every K-map, we always have to try and make the biggest subcube which is possible. हमें सबसे बड़ा subcube बनाना है. We try to make one of the biggest subcube, correct? तो यहाँ पर what you can even do is, you can do it something like this. You can only combine these two ones, but that will not create a biggest subcube. When you create a biggest subcube, in that case, the number of variables that it can represent can also be, जो number of variables ये represent कर सकता है, उसको हम minimize कर सकते हैं, और you can say minimize the number of literals. Now, if you look at this entire subcube here, इस पूरे subcube में AB is remaining and everything else is changing. So AB will be in the solution. In this subcube, only AC is not changing, others are changing. In this subcube, only AD is not changing, others are changing. Okay? ठीक है? Clear है? Now there is something very interesting property. यहाँ पर एक बहुत ही interesting property है. There is something very interesting. देखो, this is representing the number of variables in a function. Number of variables in a function. Okay, fine. And this is representing the size of subcube. This is representing the size of subcube. इसको थोड़ा सा ध्यान से समझिएगा. Please focus on it clearly. So this K-map is representing a total size of, this K-map is having total 4 variables. How many variables are there? We are having 4 variables, which is A, B, C and D. We are having 4 variables. Total 4 variables are there. ठीक है? Now what is the size of this subcube? इस subcube का size कितना है? So this subcube is having a size of 4. So if this subcube is having a size 4, now this 4 can be represented by 2 raised to power 2. 2 raised to power 2. Now this 2 is important. ये जो power वाला 2 है, this 2 which is coming in the power, this 2 is important. Why this 2 is important? Because in this subcube which is of size 4, the number of variables will be 4 minus 2. ये 4 कौन सा है? The number of variables. ये 2 कौन सा है? This 2. Okay? Clear? Okay, let me explain you one more time. देखो, if I make a smaller subcubes, अगर मैं if I try to make only this subcube, अगर मैं आपको सिर्फ ये वाला subcube बनाने की कोशिश करता हूँ, थोड़ा फोकस कीजिएगा, प्लीज फोकस हियर. If I try to make only this subcube, right? So this subcube is of size 2, that means 2 raised to power 1. 2 raised to power 1. Now the minterm that this subcube will be representing, ये subcube जिस minterm को represent करेगा, that minterm will be having 4 minus 1 variables. इसकी जो भी minterm बनेगी उसके अंदर 4 minus 1 variables होंगे. 4 कहाँ से आया? Total number of variables are 4. ये 1 कहाँ से आया? That is 2 raised to power 1. So जितना भी subcube का size है, जो उसकी power है, उसको अगर आप 4 से subtract करेंगे, then you will find out that how many variables can be minimized. अगर आप इस subcube को check करेंगे, then you will find out that A is not changing, B is changing, as well as C complement and D is remaining the same. तो C complement और D है, वो यहाँ पर same है. So this subcube will be of size, क्या size होगा इसका? This subcube is of size 2, therefore 3 variables will be there. यहाँ पर 3 variables होंगे. Okay, let me take more examples, then you will understand. Okay, so we have this expression. Let us try to first minimize this expression, then maybe you can understand from this. Okay, so here this is a function of 3 variables. Function कितने variables का आपके पास? 3 variables का है. So I'm going to make a K-map with 3 variables. Okay, so a 3 variable K-map will be having total of 4 cells. So I'm taking a variable A here, I'm taking a variable B and C here. ठीक है, step by step I'm doing everything ताकि आप सभी को समझ में आए. If you, I think you should be able to follow me. आप सभी मेरे को follow कर पाएंगे इसके बाद. I want all of you कि आप मुझे इसके बाद follow कर पाए. Okay, now this is representing a 3 variable K-map. So this location is representing 0, this is representing 1, this is 0 0 0 1 1 1 1 0. ठीक है? Okay. Now the first value here is A B complement C. That means 1 0 1. 1 0 1 मतलब 5. ठीक है? So I can also give them a number. मतलब basically क्या होता है कि if you give them number, it becomes very fast to solve these equations. तो I do not really need to write this. मुझे ये लिखने की जरूरत नहीं है. I do not have to write it. Why I do not have to write it? I can just directly give it number. I can say it is cell number 0, cell number 1, cell number 2, cell number 3, 4, 5, 6 and 7. Now this is representing value 5. This is 0 0 1 which is 1. This is 0 1 1 which is 3. This is 1 0 0 which is 4. This is 0 0 0 which is 0. अब आप clearly कह सकते हैं ना, you can clearly say that at location 0 we are having a 1. At location 4 we are having a 1. At location 3 we are having a 1. At location 1 we are having a 1. At location 5 we are having a 1. So these are the locations जहाँ पर आपके पास 1 है. Clear है सबके साथ? Is it clear? अब थोड़ा सा ध्यान दीजिएगा because this part is little tricky. अब थोड़ा सा tricky part आएगा, so I want all of you to focus here. So I want to make the biggest subcube that is possible. जो सबसे बड़ा subcube possible है, मैं वो बनाना चाहता हूँ. So I can make this subcube. Correct? This is the biggest subcube. So this one will not be included in this. Why? Because the size of subcube will only be in the powers of 2. Secondly, I can make this subcube. So this subcube is also essential prime implicant, as well as this subcube is also essential prime implicant. ठीक है? अब कुछ चीजें एनालाइज करते हैं. Before I give you the solution, let me analyze a few things here. So the size of this entire subcube is 4. ठीक है? क्या size है इसका? 4. And 4 can be written as 2 raised to power 2. ठीक है? यानी कि इस subcube से जो भी मेरे पास expression आएगी, that expression will be having 3 minus 2 is equal to 1 variables. उस एक्सप्रेशन में सिर्फ एक ही वेरिएबल होगा. What is 3? 3 is the number of variables in this expression. What is 2? 2 is the power. ठीक है, so let us look at this one. 0 1, this is 0 0 and this is 0 1. So we can clearly see A is changing as well as C is changing. The only thing that is not changing is B. So from this subcube I can find out B complement. ये जो subcube है वो सिर्फ B complement को represent कर रहा है. That means only one variable is there. Okay. Now let us look at the second one. If you look at this subcube here, the size of this subcube is 2 and 2 can be written as 2 raised to power 1. 2 क्या लिख सकते हैं हम लोग? 2 raised to power 1. So now we have 3 variables and if I do 3 minus 1 that is equal to 2, यानी कि इस subcube से मेरे पास जो term आएगी, the expression that I will get, in that expression only 2 variables will be there. जैसे what I can do here is, if you look at it here, A is not changing, right? So it is 0 0 0 1 and 1 1. So A is not changing, only C is changing. C change कर रहा है, B is also not changing. Therefore, this one is representing A complement and B complement. ये जो subcube है, I'm so sorry, C is not changing, only B is changing. C जो है वो change नहीं कर रहा, सिर्फ B change कर रहा है. Okay, so B is changing from 0 to 1, but C is remaining the same. C जो है वो 1 है, therefore here I will get A complement C. यहाँ से मुझे क्या मिलेगा? A complement C. Therefore, what is the solution here? What is the solution equation? The solution will be B complement plus A complement C. Solution होगा आपके पास B complement plus A complement C. This is the solution equation for this given expression. ठीक है, ये इस एक्सप्रेशन के लिए सॉल्यूशन इक्वेशन होगी. ओके, आई होप यू अंडरस्टूड दिस. आप सभी को ये सॉल्यूशन समझ में आया होगा. लेट अस डू वन थिंग. इन द नेक्स्ट वीडियो लेट मी टेक फ्यू एग्जांपल्स ऑफ सम बूलियन एक्सप्रेशंस and let me try to solve those boolean expressions. Okay, we'll meet in the next video now.